All right, so in the last videos we saw how sometimes you couldn't factor if things were quadratic in nature, but that didn't mean that we would give up. You could use the quadratic formula, you could complete the square. This one though, this one is kind of a pain. And the reason that it's a pain is because you have cosine of theta, and then you just have like a regular theta running around. So sometimes, and usually the book or my math app will tell you, you just need to go to the calculator for it. And so that's what we have to do. So let's go to the calculator and let's see if we can find the solutions. Now keep in mind, we want solutions between 0 and 2 pi. So for my y equals, we've got 4 cosine of, well, it says theta, but we're doing x, and we know this. Make sure you close up the parentheses though, because if you don't, it's not going to work out right. So minus x. And for the other equation, we want 2. For my window, x is going from 0 to 2 pi because that's where we're looking for our solutions. And let's make the y scale be, for funsies, let's say pi divided by 6. The y min, I think I'm going to leave this as, this could be 4, 4. I'm going to leave it at that because I'm not sure exactly what this is going to do. So 4 cosine theta minus theta. That's actually turned out to be a pretty decent window. I am speechless. All right, so it looks like we have just one and only one solution. Well, we know how to get there, right? So second, calculate 5 for the intersection. Graph number 1, graph number 2, guess that's fine for me. And it points us all the way back over here. So then our solution is approximately 0.7966. 0.7966. Now here's something fun that you can do. If you quit out of this, you come over here and you were to press X, it's going to remember the X from the intersection window that you just did. So now we can check our answer. 4 cosine of X minus X. Does this give me 2? There you go. So again, this is not something that we can do by hand. We've got to go to the calculator for that. Now, so just don't think I'm always going to go to the calculator. Sometimes you don't always have that option. But sometimes it says use a graphing calculator. All right, let's take a look at this next one. So we have cotangent squared of theta is equal to 1/2 cosecant of theta. Well, I do know that cotangent and cosecant are connected to each other through a Pythagorean identity. That Pythagorean identity says 1 plus cotangent squared is equal to cosecant squared. So that means cotangent squared here is going to be cosecant squared minus 1 is equal to 1/2 cosecant. So it looks like we might have something that is quadratic in nature. Okay, so let's move that cosecant from the right to the left. And then I really don't want the fraction in there, so I'm going to multiply everything here times 2 to clear out the fraction. This isn't mandatory, but boy, it sure does help. So now you don't have that fraction for a coefficient, and everything looks just swell. I think it is in our best interest to do a u substitution here. So let's let u equal the cosecant of theta, which turns this into 2u squared minus u minus 2 equals 0. So now this is the guy that I want to solve. All right, square root property doesn't work because I have u squared and u. I can try to factor using the AC method. That'd be 2 times 2, which is 4. Other factors of 4 that can subtract to give me 1. No, so factoring doesn't work. Completing the square. Well, if we're completing the square, you'd want to have a 1 right here, and you'd want this guy to be even. I can divide everything by 2 so that I have a lead coefficient of 1, but that then gives me fractions, and it undoes what I was trying to do in the first place. So we want to look at this using the quadratic formula. So again, quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So u, negative b is going to be positive 1 plus or minus the square root. B squared is 1 minus 4ac is negative 4 times 2 times negative 2. That gives me plus 16, all divided by 2 times a. Since a is 2, we get 4. So u equals 1 plus or minus the square root of 17 divided by 4. Now, keep in mind that u was a placeholder, hence doing u substitution. It was a placeholder for the original guy, which was cosecant. So we want to see, when does cosecant of theta equal 1 plus the square root of 17 over 4? Or when does cosecant equal 1 minus the square root of 17 over 4? Now, you'll notice that we don't have an inverse cosecant button. We don't even have a cosecant button on our calculator. That's okay, because remember that cosecant is the reciprocal of sine. So I can flip this guy over and just turn him into sine, which means I would have to flip this fraction over here over and say 4 over 1 plus the square root of 17. See? Works out nicely. So you have this, or over here, sine would equal, flip this fraction, 4 over 1 minus the square root of 17. All right, so let's see what we can do here. Again, keep in mind, we're looking from 0 to 2 pi. All right, so Mr. Calculator, we got 4 divided by the quantity, 1 plus the square root of 17. Okay, so the answer we get here is 0.7807, which sine can be. So we're going to do inverse sine of this result. And that tells me that sine, or excuse me, that theta is going to be approximately 0.8959. All right, so again, I want to make sure we understand how things work. Sine being positive is supposed to give you results that are in these two quadrants. When you do inverse sine, it gives you an answer that's either in quadrant 1 or quadrant 4. So this first answer that it gives us is going to be this guy right here. So this is our theta. But we know there's going to be a corresponding one over here. That one that's in quadrant 2 is going to be pi minus that first theta that we found. Because you're going all the way over here and you're backing it up, that theta measure, because that ends up being a reference angle for us here. So the other answer is going to be, second pi minus this answer. So that's our one solution. Second solution is going to be 2.2457. And we're going to check this here in just a moment. Now, for this other part here, I've got to do 4 divided by the quantity 1 minus the square root of 17. What did I do? Oh, I think I know what I did. No, hold on. Okay, now that's good. Now see, this gives me negative 1.28, which is outside the range that we can have for sine. Again, sine, just like cosine, has a range of negative 1 to positive 1. So there's no value, there's no theta that can give you a sine of, that's going to give you a negative 1.28. It's not possible. So here, there would be no solutions, and this would be all that we have. Now, if we were to try to graph this, So it's clear what we had from the last problem. If I want to do cotangent squared, that means I need to do 1 divided by tangent of x, square that. And then the other equation is going to be, it says 1/2 cosecant, so it means 1/2 times 1 divided by sine. And that's going to give me the 1/2 cosecant. And let's see about the graph here. See if this stuff shows up. I may have to change some things. We'll just have to see. Oh, that's not good. Where's the, oh, there's more of it. Okay. And how about the other one? We have, there's one intersection point. There's 2. And then, okay, you see that? So what happened here is that when I did 1/2 cosecant, cosecant is the red part right here. And if you remember how cosecant and secant look for graphs, you've got these little, cups and valleys that, they keep doing this as they go across. But since we have the square on the cotangent, this right here is positive and is never going to intersect with this negative piece right here. So we just have these 2 solutions. So let's verify our results. So calculate intersection. First is good, the second is good. Now here's the thing. We want our guess to be close to this first one. So we don't want our guess to be pi. Of course, pi's not even, it's going to give us something that's undefined. My first answer was like 0.89. So let me say my guess is, you don't even have to move left and right. You can just type your answer. I think it's going to be 0.7. And it tells me, thinking 0.8959. That's what I've got. But I see that there is another solution. So let's go to the calculate menu, intersect, first one, second one. Now this guess needs to be closer to this one. So let's guess 2 and see if that gives me the other solution. All right, so typically the way that it works is it's going to be trying to narrow down starting from 2. It's going to be looking for the differences between these guys until you get to something where they have that difference and it gets closer and closer to 0. So yeah, 2.2457. So cool. We're able to verify our work. We can kind of see how the graphs work and see why we don't have solutions on the other half of that graph between 0 and 2 pi. All right, so you got to make sure you know your identities. We use the Pythagorean identities so many times. See things that are quadratic in nature, know how to factor, know how to use the quadratic formula, how to complete the square, and make sure you know your basic values. Like, when does sine give you something that's 1/2? That's going to be a pi/6 and 5pi/6. You need to know that. Make note cards, make flashcards, and go over them daily. Who knows? You might become just like me.